Good afternoon, my dear students. Today is 20 April 2026, Monday. Today we will continue with the real numbers chapter. Okay. Now we have to prove that root 3 is irrational. For Cbse Class 10 Mathematics Board exams, this root 3 is irrational question is very important. Okay. It's very important. Now, how to prove? We will take a contradiction. Okay, means we will take a negative approach. Means we have to take that we have assumed that root 3 is rational, and then again we have to prove that root 3 is irrational, because of we cannot prove that root 3 is rational. Okay. Our primary assumptions contradicts the facts. We assume root 3 as rational. Our assumption contradicts some primary facts. Okay. Then we prove that because it is contradicting the primary facts, basic facts of mathematics. Root 3 is irrational, like that we have to say. Okay. Now, on the contrary, let us suppose root 3 is rational. Let us suppose root 3 is rational. If root 3 is rational, it can be written in the form of p by q. Root 3 is rational, it can be written in the form of p by q, where p and q are integers. P and q are integers, q not equal to 0. Why q not equal to 0? Division by 0 is not defined. Division by 0 is not defined. Now root 3 is equal to p by q. First suppose root 3 is equal to p by q. First suppose p and q both have common factors. Okay, both have common factors. What we will divide both p and q by all the common factors, such that p by q reduces to its co-primes form. P by 2 reduces to its co-primes form. For example, let us check 18 by 20, 24. If this reduces to its co-primes form, what it become? 3 by 4. 3 and 4 are co-primes. Okay. So what we have divided? By all the common factors. Okay. Both 18 and 24 we have divided all the common factors. Okay. What is the means? Divided by 6. 18 divided by 6. Or divided by 24 divided by 6. That is equal to 3 by 4. Okay. This is how we are taking the approach. And reducing it to common co-primes. P by Q form is basically reduced to A by B form, where A and B are co-primes. Root 3 is equal to A by B. Implies A is equal to B root 3. B root 3. Squaring on both sides. SQBS. Squaring on both sides, A square is equal to 3B square. A square is equal to 3B square. A square is equal to 3B square means what? A square is divided into 3 and B square. A square is divided into 3 and B square. This means the factors of A square are 3 and B square. The factors of A square are 3 and B square. This means what? 3 divides A square. 3 divides A square. Now if 3 divides A square, we have learned in our earlier theorems that 3 divides A also. Means what is the theorem? If P divides A square, then P divides A, where P is a prime number and A is an integer. Okay. P is a prime number and A is an integer. If P divides A square, then P divides A. Okay. In this, considering the same theorem, if 3 divides A square, then P divides A. So if now 3 divides A, okay, let A is equal to 3C, where C is an integer. 3 divides A means what? 3 divides A square means what? 3 divides A means what? A can be written as 3 into some integer. A can be written as 3 into some integer. Okay, A is equal to 3C. Now A is equal to 3. Squaring on both sides, A square is equal to 9C square. A square is equal to 9C square. Now we have got that a square is equal to 3b square. Substituting the 3b square for a square, 3b square is equal to 9c square, b square is equal to 3c square. B square is equal to 3c square. Okay. This means b square we have got 3c square. This means 3 divides b square also. This means 3 divides b square also, and hence 3 divides b. This means 3 divides b square also. This means 3 divides b square and hence 3 divides b. Now, since 3 divides b square and hence b. Since 3 divides b square and hence b. This means 3 divides b also. Okay. Why? Because since 3 divides b square, it divides b also. Okay. Now 3 divides both a and b. 3 divides both a and b. If it is dividing both a and b, our fundamental is the what we have got in a, we have reduced both a and b to co-primes. Now they are no longer, if 3 divides a and b, they are no longer co-primes. Okay, this contradicts the fact that a and b are co-primes. This contradicts the fact that a and b are co-primes. So why this contradiction has arisen? Because of our incorrect assumption that root 3 is rational. Therefore, root 3 is irrational. We have incorrectly assumed that root 3 is rational, and because of that, we are contradicting the fact that a and b are co-primes. Therefore, root 3 is, this contradiction why it has arisen is like because of our incorrect assumption that root 3 is rational, hence root 3 is irrational. Okay, simple.